And welcome back. And we're on to the 5th of Feb, core bit 5 a day, further maths. Let's go with the first question, which, having seen it from afar, looks a bit like a graphing question. It is indeed. Okay, it's a piecewise function. So I have a function which does different things between 0 and 2 that it does between 2 and 5. So let's start with the linear part of the equation. So between 0 and 2, I know it's linear because it's a linear equation. So if I put 0 in, 9 minus 0 is 9. So my first point is going to be 0, 9, which I'm going to mark on the graph. If I put 2 in, that's going to be 9 minus 3 times 2, which is 9 minus 6, which is 3. So 2 goes to 3. Now, I can't do this on my iPad, but you should get a ruler out as carefully as you can, join these points up with a nice straight line. That's not too bad. Then I've got a quadratic. Now, what I care about is a couple of things. So one is where the turning points are going to be. 2 is the shape, and 3 if I meet the original points. Let's start by putting x equals 2 into the quadratic. So that's going to give me 5 minus 2, which is 3, times 2 minus 1, which is 1, which gives me 3, which means I start at the point 2, 3, which is exactly where I left the previous function. So that's good, good start. The other thing I'd note is the solutions to this, or the roots to the quadratic, are going to be the values 5 and 1, because that's what solves this equation here. Now, 5 and 1, if I add them together and work out the midpoint, is 3, which means the turning point is at 3. In other words, the turning point is halfway between the roots. So at x equals 3, the quadratic is 5 minus 3, which is 2, times 3 minus 1, which is 2, which is equal to 4. So I know I've also got a turning point at 4. Then I need to carry on going, so let's put the point 5 in. So if I put the point 5 in, well, we already know that's a root because 5 minus 5 is 0, so it doesn't matter what the other one is. So therefore it's going to go through 5, 0. So I'm going to carefully try and draw something that looks a little bit like a quadratic that's going to come down to here. And actually I haven't done a bad job there. I've got the turning point, I've got the meeting points, I've got the root 5, 0 in. Good first question. Nice sort of way of thinking about that one. Next question. I had a very similar question to this yesterday, didn't we? So yeah, you may know other roots, and to be honest, if you've heard the words product rule, I don't think it's much quicker. You might as well just expand the brackets. So if I expand the brackets, y equals 3 minus, well, 1 minus 4x is minus 4x. 3 minus 2x is minus 6x. So 4x minus plus 6x is minus 10x. Minus minus is a plus, so plus 8x squared. Which means if I do dy dx, that's going to give me minus 10 plus 16x. And that's that question done nice and easily. Next question. Prove that. Okay. Almost always, especially at further maths GCSE, the way of doing this question is to use sine and cos, and almost always it will work out neatly because you don't know the inverse of sine and cos, you don't know cosec and sec and the other ones yet. So I would tend to start by just writing it as sine and cos. So 1 over tan is going to be cos theta over sine theta, and tan is going to be sine theta over cos theta. I now need to make the denominators the same, so I'm going to multiply the left one by cos, so that's going to give me cos squared theta. I need to multiply the right one by sine, which is going to give me sine squared theta, and that's all over sine theta cos theta, which is my desired denominator. And of course, this is all about recognising that cos squared plus sine squared is 1, and that gives me the answer I need, cos theta sine theta. Now, I would play it safe in an exam. I would actually write down that sine squared theta plus cos squared theta equals 1, because it's a proof question and you just want to make sure you haven't just written the answer down without understanding it. Either way, that's it. Question done. Again, as ever, well done if you got all of those. Nice little mix of questions today. Really love these questions. I feel the need to say it regularly, but I do. Do like, subscribe, and I'll see you for the next one. Thanks all.